This is going to be a series on factoring, and of all the things I have ever tried to explain to anybody, this is the thing, well, not that difficult, is one of the hardest to remember. So even after you learn this, you're going to find yourself having to practice and practice and practice and come back to this, particularly after a summer holiday. These are still going to be used in other grades. You're going to have to try and learn it again. It's very, very easy to forget because a lot of the things that are involved are really counterintuitive. So factoring is one of those problems that works backwards. So if I ask you the question, what is 3, if I can get even these settings right, what is 3 times 7? It's enough work to say the answer is 21. It's a harder question to say, if I give you the number 24, what are 2 different numbers that multiply to give that? And that's a harder question to answer. You can see there's a bit of a guess and check aspect to it. And the thing that you'll notice is that the more someone did their regular, the more someone did their regular times tables, the easier they are going to find a question like this. So factoring is the opposite of is contrasted with the distributive property. So questions like this, which you can answer this way. Three times x is 3x, and 3 times 2 is 6. That works that way. So factoring would be the question of taking something like this and then imagining what it would have looked like before. And there is a bit of a guess and check to it. And again, the more of these kinds of questions that you've done, the easier you are going to find these kinds of questions. So let's get on, let's do some examples. This is the first kind, which is called common factoring. And you are going to find that the easiest way to understand this, the way it's going to make the most sense, is just to see lots and lots of examples to get the hang of it. So how about 5x plus 10? And it is called common factoring, so you want to look at what these things have in common. And the distributive property, this sort of action that gave rise to all this, this was all about multiplication. So when we say, what do 5x and 10 have in common, it's what do they have in common in terms of multiplication. So the answer in this case is they're both divisible by 5. And the metaphor you're going to use for yourself is pulling out. So distributive property was about giving, and factoring is about pulling out. So I will pull towards the front a factor of 5. And what is left is x plus 2. And the thing with factoring is, if you ever want to know whether or not you did it right, is you imagine giving this question to somebody who is learning the distributive property and ask what would they do? They would do this, they would do that, they would get 5x plus 10, sorry, that 5's looking like a 6 for a second. They would get 5x plus 10, and that is the same as that. So this answer, this answer is going to be right. And we're just going to do 3 more examples of this really quickly, and we'll do binomials, so things with 2 terms. 6x minus 18. So both of these numbers, the 6 and 18, are divisible by 6. So I can pull out a factor of 6. And this would be x minus an 18 divided by 6 is 3. And again, if you're not sure if this is allowed, what would somebody do if they were given this question? 6x minus 3. This is 6x minus and 6 and 3 is 18. So they get the same answer. Notice a couple of things. That these are always going to be true. If I start with 2 terms before I do factoring, I will have something outside of brackets, and I will still have 2 terms inside the brackets after I factor it. So factoring is not going to change the number of terms. Let's do one more, which is a little bit of a different flavor. We will do y to the power of 3 plus y. Now, both of these are divisible by y. So I can put a y in front of a bracket. This would be y squared. And y take away y, or y divided by y, strictly speaking, is 1. So again, the number of terms stayed the same. What they have in common, you pull out in front of a bracket, and you're left with the same number of terms inside the bracket after you're done. Now let's try and do it with just more terms. So 6x squared y minus 2xy squared plus 8x cubed y cubed. I made it up. It's an example. It's long. And you look. So if I were to put brackets here, what could I put in front? That is, something that could be distributed to all 3 of them and show up in these 3 places. Well, all of them have an x. All of them have a y, and all of them are divisible by 2. Now, what would have to go in each of the 3 places? You stare at them, and you can either do this in a very straightforward way. You can do this as division. So you can do 6 divided by 2 is 3. Or you can just imagine filling in the blanks on a times table. 2 times what is 6? And the answer is 3. 2 times what is 2? Well, this is 1. And 8 times what is, 2 times what is 8? And the answer is 4. X times what is x squared? That's x. Y times what is y? That's just 1. So in this case, I will write this in, but you don't have to write. But you don't have to write that. And the same thing, this x takes care of this x, but you do need 1 more y. And here you need 2 x's and 2 y's. And of course there's a minus here and there's a plus here. There were 3 things before, 3 terms before, and there are 3 terms in the brackets. And if I gave this question to somebody who was just learning, they would do all of these multiplications. This would be 2 times 3, 6, x times x, x squared, which is exactly what it should be, y times y. A minus sign, 2 times 1 is 2, x times there would be 2 y's. And the last one, plus 2 times 4 is 8, x times x squared is x cubed, and y times y squared is y cubed. So this step is not necessary, it's just a check. And it's really interesting if you're doing a test which is strictly on factoring, you can do these checks and you can actually know in advance whether or not you got the right answer. Now, this turned into a mess. I'm just going to take exactly the same question one more time and look at it in real time. So this was 6x squared y minus 2xy squared plus 8x cubed y cubed. So this would be equals, I would look for something to put in front of a bracket. I may or may not write it, but I'm looking for 3 empty spaces to fill, and I know that there will be a minus sign here and a plus sign here, and looking for something in common. So all 3 of these are divisible by 2. There is at least one x in all of them. There is at least one y in all of them. And then I go through this process of filling in the blanks. 2 times what? 3. An extra x makes x squared. No extra y's are needed to make y, so that's fine. 2 times what is 2? 1. X times x doesn't, nothing needs to be there, and we just need 1 y. And the same thing, 2 times what is 8? 4. X and another 2 x's will make x cubed, y and another 2 y's will make y cubed. And the last thing that I will say before moving on to the next is what happens if one of these numbers is negative. So if you're doing distributive property questions like this, negative 3x, x minus 2, when you go to distribute, then the signs will change. So negative 3x squared, negative times a negative is a positive, 2 times 3 is 6x. So if you find yourself in the situation you're looking what you can pull out, if you are factoring something like negative 4y cubed plus 16y squared minus 12y. I will have brackets. I will have 3 things. But if I decide that I want this minus 4 to be here, remember in this example when we distributed, this went from being plus minus to minus plus because the negative went into all of the pieces. So on this one, all of the signs will change. So this will stay the way it is. This will become minus, and this will become plus. Why? Because when a minus multiplies this one, it will become negative 4. When a minus multiplies this one, it will become minus times minus, it will be plus something. And when a minus multiplies this one, it will be minus times a plus, which will be this minus. So when you pull out a negative, then the signs of everything that are inside change. And let's just go through and let's do all the rest. So if I pull out a 4, I got so distracted talking about the negatives, I realized that all of these also contain y's. So there is one y, and this will be y squared. 4 times what is 16? 4. Y and one more y will make y squared. And why no y? Just a 3. And because my answer was messy, negative 4y, y squared minus 4y plus 3. So that's a basic introduction to common factoring. There are many, many more different kinds of factoring, and this is not going away. it is going to come up very, very often that we want you to do factoring in a question, and we want you to do factoring as a small part of a much larger question. So in the same way that we now ask you to multiply numbers or ask you to add numbers, and we don't really feel any obligation to warn you that we're about to do that. We expect you to be able to do it all the time. The same thing is now going to happen with factoring. And this is something you want to practice a lot, because you want to be able to do it not only quickly and accurately, but you want to have enough practice at it so that if we stop talking about factoring now, but it becomes important in a month and a half, 2 months, that you still know how to do it. So stay tuned for another one, and we will work on the harder versions in a moment. Thanks.